Good morning, students. Okay, today we'll discuss ozone, the last topic in 16th group. Okay, before seeing the ozone, where the ozone is present in atmosphere, we'll see. After that, we'll see the very important concept of ozone. Okay, here atmosphere classified into four spheres. One is troposphere, 0 to 10 kilometers range height. Okay, 0 to 10 kilometers range height we call as troposphere. Here we have the oxygen. Okay, here 10 to 50 kilometers. Okay, 10 to 50 kilometers height we call as stratosphere. Here we have the ozone. Okay, here we have the ozone here. Okay, 50 to 100 kilometers range sphere we call as mesosphere. Ionosphere, this is also simply we called as thermosphere. Okay, thermosphere. These are the four layers present in the atmosphere. Okay, here in stratosphere we have the one ozone layer. Blue color layer that we called as ozone layer. Already we know about the importance of ozone. Okay, ozone layer protect the earth from the excessive concentration of UV radiation which is evolved from the sunlight. Okay, here then we discuss about the ozone. The formula of ozone is O3. How we'll prepare the ozone? Okay, ozone is prepared by using silent discharge method. Here I am taking discharge tube. Okay, here I am taking one discharge glass tube. Here we connect anode and cathode. We connect the anode and cathode. Okay, here I am taking dry oxygen. Okay, then pass the electricity through anode and cathode. Anode always present at left side. Anode means it attract the anion means positive charge. Cation attract the cation means cathode. Anode, cathode. Okay, pass the electricity through this discharge tube. And here dry oxygen converts into ozone by the gaining of energy. So it is one of the endothermic reaction. This is the one important point. The conversion of oxygen. Okay, here I am taking 3 moles of oxygen converts into 2 moles of ozone in the presence of silent discharge. Okay, this is the one of the endothermic reaction. Here some of the enthalpy, heat was evolved that we indicates with delta H. Okay, delta H is here plus 142 kilojoules per mole. Here we get the ozone. The concentration of ozone formation which is formed by the this silent discharge method. Okay, the concentration of this one only 10%. That means remaining 90% here we have the oxygen. So this 10% ozone we simply called as ozonized oxygen. Okay, 10% ozone. What is the meaning of ozonized oxygen? 10% ozone we called as ozonized oxygen. 10% ozone we called as ozonized oxygen. If we require more concentrated ozone, we will use the battery ozonizers. Okay, we will use battery ozonizers. By using battery ozonizers, instead of this anode, cathode and simple battery, we use the battery ozonizers. By the silent discharge, we will get the more than 90% concentrated ozone. We will get the more than 90% concentrated ozone. Okay, how we will prepare the more than 10%? How we will prepare the more than 10% ozonized oxygen or ozone? By using battery ozonizers. Okay, this is the simple preparation of ozone. Okay, in continuation we'll see the properties of ozone. Okay, here we have the physical properties and chemical properties. First we'll discuss the physical properties. Okay, physical properties of ozone. Okay, here ozone available in gas form, ozone available in liquid form, ozone available in solid form. Okay, here in gaseous state it is in different color, liquid state different color, and solid state different color. Okay, in gaseous state it is a pale blue color. Okay, here in liquid state it is a dark blue color. It is a dark blue color, and in solid state violet black color. In solid state it is a violet black color. Okay, it is a completely dissolved in water. That's why we have the ozonized water available in the market. Okay, here the boiling point of this ozone is 101 Kelvin. 101 Kelvin. This is the boiling point of ozone. Very low boiling point. Okay, very low boiling point, and it protects from the UV radiation to the earth or living organism. Okay, here these two are the physical properties of ozone. Then in continuation we'll see the chemical properties of ozone. Chemical properties of ozone. When we are considering chemical properties of ozone, here ozone easily decomposes. Ozone is the unstable molecule. It easily decomposes into oxygen. That okay, by the heating, by the providing the small amount of temperature, it easily decomposes. Okay, we'll see that one. Okay, first chemical property of ozone. First chemical property of ozone, thermal decomposition. Thermal decomposition. Okay, ozone, 2 moles of ozone easily undergoes by heating only, by the gaining of some amount of energy, by the loss of some amount of energy. Okay, here it converts into oxygen. Okay, here it loses the amount of energy. Okay, when ozone converts into oxygen, it loses the some amount of energy. So it is exothermic reaction. Okay, exothermic reaction. Here delta G means Gibbs free energy is negative. Energy was released now, so Gibbs free energy was negative, and delta S is the positive. Entropy is the positive. Entropy increases. Ozone to oxygen. The conversion of ozone to oxygen means, okay, here the density decreases. That means entropy increases. Entropy increases means delta S value is positive. Okay, here energy was released. That means, okay, delta G is negative. Okay, this is one of the important term. Okay, for the 1 mark question, what are the condition? What are the properties changed of Gibbs free energy and entropy when the conversion of ozone into oxygen? Okay, here entropy increases, Gibbs free energy decreases. That's why it is negative. That's why it is positive. This is the one simple chemical property, thermal decomposition. Then in continuation, okay, after the thermal decomposition, okay, oxidizing property of ozone. Why ozone acts as oxidizing agent? Okay, here ozone already I gave the information about ozone. Ozone easily decomposes into oxygen. Okay, ozone easily decomposes into oxygen by the liberation of nascent oxygen. This is the nascent oxygen. Nascent oxygen means newly generated oxygen. We simply called as nascent oxygen. Newly generated oxygen we simply called as, okay, here nascent oxygen. It is highly reactive. By the liberation of this nascent oxygen, okay, ozone acts as oxidizing agent. Okay, it acts as oxidizing agent. It converts, okay, lead sulfide into lead sulfate. Okay, lead sulfide into lead sulfate by the conversion into O2. Okay, here lead sulfide converts into lead sulfate, and here, and one more thing, here hydroiodic acid or potassium iodide, anyone, you take anyone, hydroiodic acid or potassium iodide, in the presence of ozone it converts into, it liberates iodine gas by the forming the oxygen, okay, here by the forming the oxygen. That means iodide ion converts into iodine, iodide ions converting into iodine. Here we are the oxygen, addition of oxygen we simply called as, okay, oxidation. Okay, here you take 4 moles of, here you will take 4 moles of oxygen, we'll get the 4 moles of oxygen, and here along with the O2, here we'll get the H2O. Okay, here we have the one relation between ozone and iodine. Okay, 1 mole of ozone involved in the reaction. Okay, here 1 mole of iodine will be, okay, 1 mole of iodine will be released. 1 mole of iodine will be released. Okay, here we will get the iodine. You take this iodine or potassium iodide solution, add ozone and liberates iodine. Okay, this iodine, take this iodine in a conical flask. Take this iodine in a conical flask, and okay, and here titrate with the hypo solution which is taken in a burette. This taken conical flask. This one means, okay, here potassium iodide and ozone taken to the conical flask, and we get here iodine. Okay, this can this iodine molecule, iodine solution, titrated against the hypo solution, okay, which is taken in a burette, and we'll get the, okay, how much amount of, okay, ozone is involved in this. Okay, how much amount of ozone is involved in this reaction? We have to estimate, we have to calculate, we have to determine the amount of ozone. Okay, amount of ozone by using this reaction. This we called as quantitative estimation of. Okay, how will estimate the amount of ozone by the reaction with potassium iodide solution and hypo. This we called as quantitative estimation of ozone. How we identified, the one more question, how we identified the, okay, how we identify the amount of ozone estimated or identified, okay, determined by the iodine, okay, titrated against the potassium iodide, iodine solution against the hypo solution, or potassium iodide and ozone mixture titrated against the hypo solution, which one taken into the burette. This is about the quantitative estimation of ozone. Okay, this is the second property, oxidizing property. Okay, oxidizing property of ozone. And then see the third property of, okay, here ozone, third chemical property of ozone. Already we know about the supersonic jet air aeroplanes. Supersonic, okay, here supersonic jet aeroplanes. Okay, here supersonic jet aeroplanes. Supersonic jet aeroplanes are always moving into the stratosphere. Okay, the supersonic jet aeroplanes releases nitric oxide, NO. This nitric oxide reacts with the ozone. Okay, in the presence of that UV light. What happens here? It forms nitrogen dioxide along with the liberation of oxygen. That means if supersonic jet aeroplanes are moving one area to another area in stratosphere, the density of ozone layer will be decreases. decreases. That means ozone converts into oxygen. Ozone converts into oxygen. This is also one of the important oxidizing property of ozone. Okay, here nitric oxide oxidized into nitrogen dioxide. And one more thread is present at the stratosphere. Okay, here already we know about the refrigerator, ACs, all coolers, air conditioned coolers, refrigerator releases the chlorofluorocarbons. Chlorofluorocarbons are all simply called as freons. Chlorofluorocarbons are simply called as freons. These freons are interact with the ozone. In presence of UV light and converts into oxygen. That means in the presence of these freons also the density of ozone decreases. Okay, into oxygen. Then ozone converts into oxygen. Okay, in the presence of sunlight. Okay, here this we called as ozone depletion. This ozone depletion or ozone hole is observed in the atmosphere at Antarctica place. Okay, that is about the. This is also one of the simple oxidizing property of ozone. Okay, here this is about the chemical properties and physical properties and preparative methods of ozone. And here uses of ozone. And ozone is good germicide disinfectant. Ozone is the good germicide disinfectant. Okay, it sterilizes the water. If you pass the ozone into water, it kill the bacteria or virus. Okay, here and we'll get the sterilized water. Okay, it is also used as a bleaching agent. Okay, it is used for the bleaching of food material, ivory material and food material and different materials. Okay, this is the importance of ozone. And then we'll see the structure of ozone. Okay, let's get resonance. It shows the resonance. Ozone means 3 oxygen atoms. Here 1 oxygen atom. Here 1 more oxygen atom. Here ozone. Here oxygen. Here O. Okay, here 1 lone pair. Here 2 lone pair. Here 3 lone pairs. 2 lone pairs. Here also same 1 lone pair. Here 2 lone pair. Here 2 lone pair. This is the coordinate covalent bond. And then we'll have resonance hybrid of ozone. This is the resonance hybrid of ozone. Resonance hybrid of ozone. These two are this one and this one. This is the resonance structure 2. This is the resonance structure 1. Resonance structure 1. And bond angle is 117 degrees. The bond angle is 11 degrees. And here bond length is 121 picometers. Bond length is 121 picometers. This is the structure of ozone, uses of ozone, and chemical properties and physical properties of ozone. This is about the ozone, and this is about the 16th group elements. Okay, in continuation we'll see the 17th group elements. Thank you, and we'll see see the next video also, continuation video. Okay, for the 17th group elements. And here, supersonic jet aeroplanes, it's one of the important question. Okay, what happened? Which type of reaction is observed in supersonic jet aeroplanes when moved into the stratosphere? Okay, supersonic jet aeroplanes releases nitric oxide. It is reacts with the ozone in the presence of UV rays. Okay, forms nitrogen dioxide. That means nitric oxide undergoes oxidation and form the nitrogen dioxide. Okay, here what about the ozone? Ozone converts into oxygen. That means the density of ozone decreases. Okay, that's why supersonic jet aeroplanes also affects the. Okay, this is also one of the threat for the ozone layers or effect on the ozone layer. Chlorofluorocarbons also affect on the ozone layer, okay, by the interacting with by the free radical reaction with the freons and form the oxygen. This is about the ozone. In continuation we'll see the one more important topic, that is 17th group elements. Thank you.